So far we have studied about the pressure belt. We have studied about the pressure belt, ITCZ, westerlies, easterlies, and how the wind is ascending and descending. Okay. So how you can better learn this pressure belt is you just start drawing the diagram. Okay. You start drawing the globe. You identify what are the low pressure, equatorial low pressure belt. From there you start and you draw all the belts. Okay, then you identify where is ITCZ and where is the westerlies, what are the polar easterlies, just identify and you just draw the direction of the wind. Okay, that is very important. Don't confuse the direction of the wind. Okay, you can see ITCZ, both the trade winds converge at ITCZ, and how the polar easterlies, westerlies put the directions correctly, and just draw this diagram 2 to 3 times. Then you are done perfectly with the pressure belts and nobody can confuse you. Okay, so that is with the pressure belts. Now we are moving on to the next topic, which is the air mass. Okay, air mass and front. What is the front and all we'll study. So first, basically, what is an air mass? You all know what is air. So now it is air mass. Mass is nothing but a volume. So air mass definition goes like this: a volume of air which is defined by its temperature and the water vapor content in it. That is an air mass. So air mass is of two types. One is warm air mass and another one is a cold air mass. So what is a cold air mass? Cold air mass is nothing but, I'll write once again. So air mass is of two types, warm and cold. Okay. So what is a cold air mass? Cold air mass is nothing but, I told about the air mass. It is a volume of air. So if in a cold air mass, that volume of air, okay, it will be having some certain temperature. Okay. If that temperature is lower than its surface, a volume of air is there and beneath that a surface is there. Okay, if that volume of air is having a temperature much lower than the surface temperature, then that is known as your cold air mass. On the other hand, if that volume of air is having a higher temperature than its surface temperature, then it is known as the warm air mass. Okay, so that is the definition of warm air mass and cold air mass. Now with this background, we will study what is a front. Okay, what is a front? Front is nothing but, we have studied warm and cold air mass. So let us assume that this is a warm air mass and this is a cold air mass. Okay, so this boundary, okay, this boundary of a warm air mass and a cold air mass is known as the front. You could have studied another term that is known as the frontogenesis. Okay. So what is frontogenesis? Frontogenesis is nothing but when a new front, okay, like this is the front, okay. So when a new front is created or when it is regenerated, then it is known as frontogenesis. And what is frontolysis? Frontolysis is nothing but a dying of a front. When a front is dying or getting removed away, then that is known as frontolysis. When it is created, it is known as frontogenesis, and when it is dying out, it is known as frontolysis. And front is nothing but a boundary between a warm air mass and cold air mass. Okay, so these are the terms involved. Now we will study what is a cold front and what is a warm front. First we will study about the cold front. Okay, earlier I have told that, assume that this is a warm and this is a cold. So when these two air mass are colliding, that boundary is known as the front. You all know that. Okay. So now here the temperature of this warm air mass and this cold air mass plays a significant role. Why is temperature has a relation with the density. Okay. So when an air mass is warm, it is having less density, and when a cold air mass is there, it is having high density. So the temperature of this both air mass plays a very significant role in determining the density. You all know when a cold air mass is having high density, then it will be having high volume. So automatically when you place a warm and a cold air mass, this cold air mass has a tendency to go downwards because of the high density or the high volume it carries. And the warm air mass always has a tendency to rise up because it is a warm air mass. It is having less density, more temperature. When there is more temperature, it always rises and expands. Okay, so that is the tendency of a warm air mass and a cold air mass. Now what is a cold front? This is the phenomenon. Okay, so when you always place a warm and cold air mass, always the cold air mass will go down and warm air mass will go up. So what now cold front means is, when this cold front, okay, when this cold fronts come and it invades, okay, this cold air mass will come and lift the warm air mass. Okay, the phenomenon is same only, but if who is giving the push, who is giving the initial push? When the cold front is giving the initial push, that is known as the cold front. Okay, let us now take, see, this is a warm air mass and this is a cold air mass. Now what I am saying is, when they two meet each other, then this cold air mass will go down and it will lift the warm air mass up. Okay, that is known as cold front. Since the cold air mass is doing this push, that is known as cold front. Okay, so when this cold front is going and pushing the warm front, the warm air mass, what happens is, at the boundary there is a narrow boundary there, and at the narrow boundary there is a more possibility of showers or thunderstorms there. So there is a more probability of rain when this cold air mass is pushing. At the boundary there will be more rain formation there. Okay, so that is with your cold front. Next we will see what is the warm front. So now, what is a warm front? In warm front, what happens is, when a warm air mass and a cold air mass meets together, now the warm air mass will do the initial push. Okay, it will go and invade and subject the cold air mass downwards. Okay, so when this warm air front is invading and suppressing the cold air mass, then it is known as the warm front. Okay, so automatically when the air mass is invading and making the cold air mass subduction, this warm air mass will rise. It will rise and expand. Okay, so when this is rising and expanding, it will leads to evaporation and condensation. More condensation is possible there, and more cloud formation will be there. When this warm front is happening, there will be a more possibility of a cloud formation. So when a cold front is happening, in that narrow boundary, there will be a sharp thunderstorm or rains occurring there, and when a warm front is there, then there is a high possibility of cloud formation there. Okay, so we have seen about the cold front, warm front, and now the next front is the stationary front. Okay, so when a cold and an warm air mass both are meeting, and both the warm air mass and the cold air mass are not having the powers to invade or lift each other, then they will stay close and they will not do any actions. No action is there. They will stay at their place itself. Okay, no invading, subduction and all. Both will stay in the same position. Then that is known as the stationary front. Okay, I'll read the definition of stationary front for your understanding. When neither of the warm or cold front is strong enough to replace the other, then the boundary formed between the two different air mass is known as the stationary front. Okay, so regarding your front, okay, front and frontogenesis, the one thing you should have in mind is two air mass, cold and warm air mass, when they come and meet each other, then that is known as the front. Since the warm air mass, the density is light, it will be having less weight, so it has a tendency to rise and expand. And since the cold front, the density is higher, it will be having high volume, so it will always have a tendency to go downwards. Who is giving the push? That depends on the warm front and the cold front. Stationary front, neither of them is giving the push and nobody is strong enough to replace each other. That is known as the stationary front. Okay, so that is about your frontogenesis and frontolysis. The next topic we are going to see is about the cyclones and anticyclones. So now we'll see what is a cyclone and what is an anticyclone. Okay, this word cyclone, you could have heard in the news. Cyclone is formed, a depression is formed. So how the cyclone is nothing but when a wind is moving faster. Okay, when a wind is moving faster, actually when air is moving, that is known as wind. Okay, when this wind is moving with a higher velocity, that is known as cyclone. Why it is moving with a higher velocity? Because of the difference in pressure. You all know the temperature is not evenly spread in the globe. In the surface of the atmosphere, the temperature is not evenly distributed. Same like pressure also. There is a variation of pressure. That's why we saw the pressure belts and all. If the pressure has been even, there will not be any belts and all. Everywhere it should be common. Since the temperature is unevenly distributed, okay, the pressure is unevenly distributed over the earth. Okay, so now you have to connect all the things. How this temperature has been, it has been unevenly distributed because of the movement of the sun. We have seen in the first module. So you have to connect the first module always with all the modules what we are studying, because that is the basic. Okay, so now my point is how the cyclones are formed because of the uneven distribution of the pressure. Because of that only the winds are moving always from the high pressure to the low pressure. So in the globe, or very precisely in the surface of the earth, there will be always a low pressure or a high pressure formed. Okay, depending on that, the wind always travels from the high pressure to the low pressure area with a high velocity, then it turns into a cyclone. Okay. So you would have seen in the news and all how the cyclone has been formed. They'll say depression is formed. They'll show a image. Okay, in that image you can see always cyclone will be like a twist. It will form like a twist and it will be just moving here and there. So why this moving is there? If take this as that move. Okay, so this is known as the center point. Okay, that is known as the eye of the cyclone, and this is very very important. Okay, the eye of the cyclone, and this outer area is known as the outer edge of the cyclone. So with regard to cyclone, what happens is this eye of the cyclone, okay, this eye of the cyclone will have a low pressure. This eye of the cyclone will have a low pressure, and this outer edge, it will be having a high pressure. Okay, which means that at the eye of the cyclone, there will be huge amount of temperature. That's why it is experiencing low pressure. At the outer edge, the temperature is minimum. That's why it is having high pressure. You all know, always the wind moves from high pressure to low pressure. So, in cyclone, the wind direction will be from outside, it will go inside. Okay, like it will be twisting, and that twisting will be from the outer to the eye of the cyclone, in the cyclone. So what is the difference of anticyclone? In anticyclone, the exact opposite happens. What happens is, we'll see. So in anticyclone, what happens? The exact difference happens. Okay, the eye of the anticyclone will be a high pressure area, which means that the temperature will be minimum there, and the outer area, the temperature is maximum, so it will experience a low pressure. So always the wind moves from high pressure to low pressure. Okay, so that is the movement of wind in the anticyclone, and that is the essential or the primary difference between a cyclone and an anticyclone. Okay, so when in a news or when you are reading newspaper, if you are hearing it is a cyclone, then always have this picture in mind. Okay, the eye of the cyclone will be for a cyclone, the eye of the cyclone will be a low pressure, and the outer area will be high pressure. So from outer, the wind will move towards the inner eye of the cyclone. So always it is from the outer to the eye in case of cyclone. If you are reading anticyclone or if you are seeing anticyclone, it means that the eye of the anticyclone will be a high pressure area and the outer will be a low pressure area. So wind in an anticyclone will move from the eye of the anticyclone to the outer edge of the anticyclone. Okay, that is the exact difference between the cyclone and anticyclone. Next we will see how this cyclone and anticyclone, what is the direction of the wind with respect to the northern hemisphere, southern hemisphere, because this is the basic direction. Okay, basic direction or the basic characteristic of a cyclone and anticyclone, but the direction of the cyclone depends on the Coriolis force. Okay, since you know what is Coriolis force, because the earth is rotating on its own axis, there is a movement in the wind direction. Okay, because of the Coriolis forces, in the northern hemisphere winds are always deflected towards its right, and in the southern hemisphere the winds are always deflected towards its left. Okay, this statement, whenever it has been asked, you should remember this statement very clearly, because Coriolis force, what to say, it is very very important. And in geography actually there are some 10 concepts, 10 lines like this, single lines. Wind always move from high pressure to low pressure, or about the solstice equinoxes. The major 10 lines are there, that you should always keep in memory. Okay, because based on that 10 logics only, all the basic concepts are there. Okay, so that is about your cyclones and anticyclones. Now we'll break the cyclones even more depther. Okay, so this is the direction of the cyclone and anticyclone with respect to northern hemisphere and southern hemisphere on the effect of Coriolis force. Okay, in northern hemisphere the direction of cyclone will be in an anti-clockwise direction. Okay, you all know what is anti-clockwise, and in southern hemisphere it is a clockwise. The exact opposite happens with anticyclone. In northern hemisphere it is clockwise, and in the southern hemisphere it is always anti-clockwise. Okay, so always remember, it will be so confusing for aspirants. So to remember this, you can have a shortcut, or like study the cyclone only. Okay, study the cyclone, and just the opposite is the anticyclone. Cyclone, it is northern hemisphere, it is anticyclone, and in southern hemisphere it is clockwise. Okay, so that is with respect to the directions. Now we will see why it is why this direction is there, why it is anti-clockwise and why it is clockwise, because of the Coriolis force I said. Now we will see why that direction actually happens. So take a photo of this direction. It is very, very important. They can ask in prelims very much. This tabular column will be very much of useful in the prelim section. Okay, so now I will explain the concept why the direction we have learned about the tabular column, why that direction has been changing. Now we will see an example. It is the northern hemisphere. We are taking the northern hemisphere, and we are going to study about the cyclones. So what really happens is, you all know this is cyclone. Okay, this is the eye of the cyclone. So always this eye of cyclone will be of low pressure, and this outer region will be high pressure. I'm talking about the cyclone. So always the wind will blow from the high pressure to the low pressure, that is from the outer area to the inner area. So wind is like this. So you all know we are in the equator. This cyclone majorly happens in the tropic area. Okay, tropic area, the tropical cyclones happen. There are cyclones of two types, tropical and temperate cyclones. So now that two types I will explain later. But now take for example, this is a tropic cyclone which is happening near the tropics, above the equator. So it is a tropic area. So what happens is, see, the northeast trade winds, you all know equator is here. So northeast trade winds and the southeast trade winds both come and converge at the equator, where you can find the ITCZ there. With this concept we all know. So now it is northeast trade winds. So what happens is, because of the Coriolis force, now the Coriolis force comes into effect. We all know due to Coriolis force, the winds are getting deflected towards the right in the northern hemisphere. We are studying about the northern hemisphere. So the wind should get deflected towards its right, means this side. So what will happen is, due to Coriolis force, this wind, okay, the wind which is coming from the northeast, it will bend its direction towards this direction. All these winds will go towards this direction, and see, it will join the cyclone. That's why it becomes anti-clockwise direction. Okay, in northern hemisphere, the cyclone becomes anti-clockwise direction because of the Coriolis force. This is the clean example of the direction of the wind. Okay, like this you can connect actually, because if you go down in the southern hemisphere, the winds are different towards the left. Okay, if you draw the diagram, you can understand why it is clockwise in the southern hemisphere with respect to cyclone. So that is the explanation of the tabular column. Now we will get into the two types of cyclone, which is a tropical cyclone and temperate cyclone. So you all know the cyclone is of two types. I told already, tropical and temperate cyclone. With the name itself you can understand, this tropical cyclone occurs in the tropics region. What is the tropics region? The area between the Tropic of Cancer through the equator till the Tropic of Capricorn. This area is known as the tropics. So if the cyclone happens in this area, that is known as the tropical cyclone. So what could be the reason for this tropical cyclone? We all know that is the area where both the trade winds near the equator converge. So this tropical cyclone is caused due to, or it is affected due to the effect of the trade winds. Because of the trade winds, the tropical cyclone happens. So cyclone is of two types, tropical and temperate. So this tropical cyclone is due to the trade winds, because this happens in the tropics region. So there is high amount of trade winds there. So because of this trade winds, this tropical cyclone occurs. On the other hand, the temperate cyclone occurs in the mid latitude. What is mid latitude? From 30 degree south or north or south till 60 degree. Okay. On the other hand, tropical cyclone happens in the latitude of 5 degree to 30 degree, north and south latitude. It is from 30 to 60 degree. Okay. So in temperate cyclone, what happens in that 30 to 60 degree? There is high amount of westerlies. Okay. High amount of westerlies will be there in the mid latitudes. So this temperate cyclone is because of this westerlies only. So that is the exact difference of the tropical cyclone and the temperate cyclone. Okay, tropical cyclone is affected due to the trade winds, and temperate cyclones are affected due to the westerlies. So what will be the direction of the tropical cyclones? You all know trade winds. Trade winds. See, this is the equator, and trade winds come from here, and it is coming from here, from the south, from the northern hemisphere. So always the direction is from the east only. Here is the east and here is the west. So east from west only, both the trade winds are coming. So the direction of the tropical cyclone will be also from the east to the west. On the other hand, the temperate cyclone, the direction of the temperate cyclone, because it is affected by westerlies, the direction will be from the west to east. That is the second difference. So first difference, tropical cyclone because of trade winds, and temperate cyclones because of westerlies. Second direction about the direction. Second difference is about the direction. The tropical cyclone, since it is because of trade winds you all know it is from the east to west, and westerlies from the west to east. That is the direction of tropical and the temperate cyclone. The third difference is about the amount of rainfall. This tropical cyclones are associated with heavy rains on a smaller area for short duration. Okay, heavy rain is there on a small area for a short duration, and this temperate cyclone will result in a long duration rainfall. Okay, so if a rain is having but low rainfall only. Okay, temperate cyclone there will be a low rainfall but for long hours. In tropical cyclone there will be a heavy rainfall but for a short duration, which is actually very dangerous. The tropical cyclone is dangerous because there are heavy showers for a shorter duration of time. Okay, so it may lead to flood. On the other hand, the temperate cyclone, there is a less rainfall for a long duration, so there is no formation of flood and all. So this tropical cyclone is always dangerous. That is the third difference. The fourth important difference is this tropical cyclones are not accompanied or not followed by temperate cyclones. Sorry, this tropical cyclones are not followed by anticyclones. On the other hand, every temperate cyclone is followed by an anticyclone. So these are the four important differences between tropical and temperate. Again, I'll repeat because this tropical and temperate cyclone is very much useful for your prelims view. Okay. So the first difference is about the cause. What is the cause? The cause for the tropical cyclone is the trade winds, and for the temperate cyclone, the cause is westerlies. Second difference is about the direction. What is the direction of the tropical cyclone? From the east to west because of the trade winds. For the temperate cyclone, the direction is from the west to east because of the westerlies. The third difference is about the amount of rainfall. For respect to tropical cyclone, there is a huge rainfall for a short duration, resulting in a flood-like situations. But in temperate cyclone, only less rainfall for a long duration. So there is no possibility of floods and all there. The fourth important difference is the tropical cyclone. Every tropical cyclone is not followed by an anticyclone. On the other hand, each temperate cyclone is followed by an anticyclone. Once a temperate cyclone has happened, it will be suddenly it will be followed by an anticyclone. So these are the difference between a tropical and temperate cyclone, and have a difference between the cyclone and anticyclone. Cyclone, the high pressure will be for a cyclone, the eye of the cyclone will be a low pressure and outer will be higher pressure, and for an anticyclone, the eye will be a high pressure and the outer will be a low pressure. So according to that, wind blows from high pressure to low pressure. That is a basic difference of a cyclone and anticyclone. Under cyclone, we are having two types, tropical and temperature. That's what the difference explains. So with that, we are coming to the end of the we have completed all the pressure belts and the front and frontogenesis, and I also explained about the cyclones and anticyclones. Next, what we'll be saying is we'll going into the climatology. So we'll study what is the climate and what types of rainfalls and the different types of climates we'll be dealing. So that is basically or broadly known as the climatology. So the next section is about the climatology. Thank you for watching the video. Please subscribe our channel, like this video and share with your friends. Thank you.